Good evening, everyone. Can you hear me all right? If you could please just make your way over and take your seats and we'll get started. All right. Can everyone hear me okay?
Yes.
Yeah? All right, fantastic. So good evening, everyone, and thank you for joining us for Safeguarding Meredith's Waters, a community forum on cyanobacteria. My name is Bree Rossiter. I am the Conservation Program Manager for the Lake Winnipesaukee Alliance, the only nonprofit dedicated to protecting Lake Winnipesaukee and its watershed now and for the future. Tonight's event is held in partnership with the Meredith Cyanobacteria Committee, which is a local volunteer group that I am proud to be a part of. We were formed under the Conservation Commission to empower volunteers and to raise awareness at a local level. I would also like to welcome the Waukewan Watershed Advisory Committee, Windy Waters Conservancy, Meredith Neck Islands Alliance, and the Winnisquam Watershed Network as part of the presentation tonight. Before we jump in and get started, I have just a few quick housekeeping notes. Number one, please silence your cell phones. Number two, restrooms are located all the way down the back of the hall towards the gymnasium. 3, please hold all of your questions for Laura until the end of her presentation. And number 4, this meeting is being recorded and will be uploaded to LWA's YouTube page. Tonight, you can expect to hear a presentation from Laura Diemer of FB Environmental on the Waukewan Cyanobacteria Monitoring Project. Following that, we will have a quick Q&A session on Laura's presentation, and then we will have a 5-minute break. After the break, we will have a panel discussion with experts from the New Hampshire Department of Environmental Services, UNH, and FB Environmental, followed by audience Q&A session. I do want to just give a couple acknowledgments and thank yous for some of the people being here tonight. Thank you to the Waukewan Watershed Advisory Committee, also known as WWAC, for sponsoring this evening's forum and making it possible, and to their chair, Donna Murphy, and to her husband, Frank, for being such invaluable partners in planning this event. I couldn't have done it without you. We also, We also want to thank Liz Cody, Mark Billings, and Betty Higley, who provided flowers, snacks, and supplies this evening. Your support is greatly appreciated. Now I am pleased to present our featured guest tonight, Laura Diemer, Certified Lake Manager, Senior Project Manager, Lake Services Lead, and Director of Operations for FB Environmental. Laura led the Waukewan Cyanobacteria Monitoring Project, and she'll be sharing key findings and a broader regional perspective. Laura, thank you for being here. The floor is yours.
Thank you, Bree. Can everyone hear me okay? If I'm right here? More? How's that? Better? Okay. Yeah, thank you, Bree, for the introduction. So, as Bree said, for tonight's forum, I was asked to give a talk on cyanobacteria, using Lake Waukewan as an example of what communities can do, not only in Meredith, but across the state in monitoring and managing cyanobacteria bloom risk. So I really appreciate the opportunity to be giving this talk tonight, but really any of the other panel members represented here tonight could also be giving this talk. We have some great expertise in this room, and we can help address any questions you have later. As Bree mentioned, I am just one in this group. We have a lot of dedicated, passionate, knowledgeable folks here tonight, as she already mentioned, from UNH Lake Monitoring Program, DES, and then LWA, Bree herself. And of course, I also want to give a shout out to the Meredith Waukewan specific groups that I mentioned here. The town of Meredith, Judy's here, thank you. Conservation Commission and Water Department, the WWAC, and any of the water quality monitors, whether you're through VLAP or LLMP, and Winnie Waters Conservancy. And there's of course so many more that I'm not listing here. Okay, so we all know that cyanobacteria is a growing problem, not only in our state, but across New England and the country. These are just some example images, some of which may look very familiar to you, of the types of blooms that we're seeing in New Hampshire. Cyanobacteria are small photosynthesizing bacteria that grow in a variety of environments, including our freshwater lakes. They come in all different shapes and sizes with different life strategies and functions that you can see here on this photo collage. And we care about cyanobacteria because they can produce microcystins or other cyanotoxins that can pose a serious potential health risk to not only humans, but also pets, livestock, and wildlife. These toxins can cause a range of issues from neurological to liver, kidney, and reproductive organ damage, or gastrointestinal pain or illness, vomiting, eye, ear, skin irritations, and sometimes death, which we typically would more see in our pets. So there's so much more to get into related to assessing and reporting cyanobacteria risk related to these blooms that I'm not going to get into great detail here, but I think that would be potentially a great discussion to have with the rest of the panel after my talk. So because cyanobacteria can photosynthesize like plants, their basic needs are generally simple. They need carbon dioxide, water, and sunlight for energy. They also require essential nutrients and minerals for growth, with phosphorus usually being the limiting nutrient for growth. So generally, the more phosphorus that's available, the more cyanobacteria will grow. But of course, it's a little bit more complicated than that. So in here, I have three major areas represented. I have the atmosphere, the watershed or the land, and the lake. So we all know that development in the watershed leads to more nutrient-rich runoff that can fuel cyanobacteria growth. We also know that some lakes can derive additional nutrient sources internally from sediments and trigger cyanobacteria growth. Now we also have climate change exacerbating these processes. So more intense rainfall is increasing nutrient-rich runoff to our lakes. Warming air temperatures are creating warm waters where cyanobacteria can thrive. All our lakes are generally experiencing similar changes in weather patterns, and most have development impacts. So why aren't all of our lakes blooming? There are other factors that come into play that can stimulate or inhibit cyanobacteria growth. And those things include food web dynamics, background geochemistry, and morphology. So that would impact like physical characteristics like flushing and retention times, water column stability, mixing patterns. Also, the composition of the cyanobacteria community. What are the dominant species in your lake that can also impact what's growing or not in your lake? And we're still really learning about the role that picocyanobacteria, the smallest size fraction of cyanobacteria, present in our lake and the risk that may represent. So while we can't control the impact of climate change on our lakes, we can manage the impact of watershed development and sometimes internal nutrients to reduce that nutrient availability for cyanobacteria growth. So I'm going to come back to some recommendations related to that later on. I did pull some data for 2024 and 2025 to help illustrate some of the climate drivers of cyanobacteria blooms and how that might change seasonally. So here is spring 2024. We're looking at May and June. The figure is showing precipitation in the blue bars and air temperature in the orange line. And I just The dashed horizontal line is just at the 70-degree mark to just generally show you where there's warming periods. So basically what we're seeing is that rain events are bringing in nutrients to our lakes, and then warming periods right after those rain events are often promoting cyanobacteria growth. So the green dots on this graph are cyanobacteria bloom reports through the DES HABS program. So these spring blooms are typically short-lived, lasting maybe a few hours to maybe a few days, but usually not more. They also tend to be dominated by fewer cyanobacteria genera, mostly Dolichospermum. They seem to thrive in these short-term nutrient pulses followed by warm, sunny days in spring. Summer is a little different, and with more bloom reporting, we obviously have more consistent warm air, and so warm water temperatures as well. Rain typically becomes lower in summer, though you can see that we did have a wet August last year, and then September was very dry. Cyanobacteria also tend to become more diverse in summer, as many are able to grab nutrients from deeper depths and thrive in more stable water columns that are created by stratification in late summer. You'll notice that there's still some correlation with rain events, but it may be less of a driving force in summer compared to spring, as some of these other factors come into play. And then fall is a little different still. So air temperatures and thus water temperatures are cooling. That means our water columns are destabilizing and they're starting to mix. And so we might start to see some deeper dwelling cyanobacteria come to the surface. Rain and air temperature seem to still be important, but nutrients from deeper depths are upwelling during this time, regardless of what's coming from the watershed as runoff during rain events. So blooms in fall tend to continue to be more diverse than earlier in the year, but they also tend to last much longer, weeks, maybe months, because often they're sustained by those nutrients from deeper depths if internal loading is significant in that lake. And then just this spring, 2025 thus far, again, we're looking at May and then June through at least June 12th. Similar patterns as we saw last year. So we have rain followed by a warming period, and then we have some cyanobacteria reports. We get rain followed by a warming period, cyanobacteria, rain, warming, and cyanobacteria. So that seems to be a common pattern, at least in spring, and then those dynamics change a bit heading into summer. So the question is, how can we stay ahead of the growing threat of cyanobacteria blooms? I want to focus on Lake Waukewan in Meredith as a model example of how a community can come together to proactively protect their water resource, which in this case is not only a recreational water body, but also the primary drinking water source for the town. So for those that may not be familiar, Lake Waukewan serves about 3,000 consumers, mostly in Meredith. It is their sole drinking water source. They have an intake pipe in the southern part of the lake in about 5 to 6 meters of water, and that gets piped to their facility, which is right across the road on the southern shore of the lake. They do have very high water quality with a limited bloom history, but they do have a history of blooms. They tend to be, at least in the past, something that's happened in the fall, shoreline accumulations, around, leading up to or shortly after fall turnover. They are impaired, according to the state, for low oxygen in their deep water, so it is a threat of internal phosphorus loading for the lake. It is a low contribution now, but it's something that they're closely tracking to make sure that it's not something that worsens over time. They have been participating in the VLAP program through DES for decades, and they've enhanced that monitoring in recent years with their strong volunteer network. They have a very engaged community with many groups that I'm going to be going over. in a second. And generally, there's just an understanding that climate change will likely make blooms more common, regardless of how good your water quality is now. And so there was a understanding that understanding that there's a need for maybe a more formal monitoring or response plan for Lake Waukewan to protect it as a drinking water source. So when we're talking about protecting our lakes, it's important to understand that it does take a lot of effort and coordination among many different groups to be successful. So I have here the term teamwork makes the dream work, and that's really how Lake Waukewan's community has been successful and proactive in their lake protection efforts. And so I just wanted to go through those key groups and what their roles have been. So we have the Waukewan Watershed Advisory Committee. That's a volunteer committee appointed by the Board of Selectmen. They were formed to implement actions from the existing 2016 Watershed Restoration Plan, and they're responsible for outreach and education for water quality protection efforts for the lake. The Windy Waters Conservancy, that's the Waukewan Shore Owners Association. They are a nonprofit watershed association, also geared towards water quality protection. Of course, the VLAP volunteers, they are sampling the lake and tributaries about 7 times a year right now. And they work very closely with the DES VLAP program, who receives and processes those samples and has regular and ongoing communication with the VLAP volunteers. Then we have the Meredith Water Department. So obviously they are monitoring the water treatment plant. They are now maintaining a new buoy and weather station that have been installed at the lake and the facility as part of a grant that I'll be talking about in a little bit. They work more closely with the DES Drinking Water and Groundwater Bureau, who has in the last couple summers been, and maybe more, monitoring the lake bi-weekly in summer to help supplement the VLAP monitoring. And they would analyze cyanobacteria samples if a bloom is suspected near the intake. And then also through DES, a different program is the Harmful Algal Bloom Program, or HABS program. They also analyze cyanobacteria samples if a bloom is suspected, but more from a recreational standpoint. So if it's outside of the radius of the intake, those samples may be diverted to the HABS program. And they would issue bloom warnings for any exceedances of recreational thresholds. And then we have the town of Meredith staff. Obviously, ultimately, their goal is to protect Lake Waukewan's water quality, so that they have good water quality supplying their town, but they would be responsible for public communications related to the lake's water quality, especially in the event of a possible bloom. So big credit to these groups for being proactive in water quality protection. Each one of these groups plays a key role, and regular communication among them is critical. So for the project that I'm about to go into, FBE, LWA, and UNH Lakeside Monitoring Program partnered on the recent $200,000 DES drinking water grant project for Lake Waukewan, and worked with this team for the last year. So the grant funded the development of a source water assessment report and a cyanobacteria monitoring and response plan for Lake Waukewan. The purpose of the project was to collect robust data over the course of one season, so that happened last year, 2024. We wanted to assess the drivers of blooms in Lake Waukewan and the overall risk of blooms in the lake, and then ultimately develop an easy-to-follow response plan for the Meredith Water Department and partners to follow. So we are currently in the final stages of the project, and we'll have final documents out by the end of this month. So for this project, we completed some intensive sampling over the 2024 season. This is just a conceptual diagram that just runs through what we did last summer. So if you start with number 1 at the top, we worked with volunteers and the Meredith Water department to do sub-weekly visual assessments. So there were a lot of eyes on the water to report anything that was suspicious of being a bloom. And those were recorded in like a Google survey form and reported to us regularly, and then certainly compiled at the end of the season. If you shift over to number 2, so we deployed a buoy, which you can see here, the orange buoy at the top, and down through the water column, we had a continuous data sonde that was situated in about 5 meters of water, which within 200 feet of the intake, which is about the depth where the pipe withdraws water from the lake, trying to capture the water that would be assumed to be taken into the pipe at that point. And that sonde was monitoring for temperature, conductivity, pH, turbidity, chlorophyll A, and phycocyanin. So phycocyanin is a surrogate measure for cyanobacteria. So we were monitoring for that. So if there was a spike in phycocyanin, it would trigger a response for us to go collect a sample, because that may be indicative of cyanobacteria near the intake pipe. We didn't have that for this season, but so that buoy was out all last year, and it was deployed a few weeks ago with our staff, but mostly the water department and volunteers like Jamie and Frank were out there deploying it. So it's back out in the water this season. We've given all the training to those folks to get it out, and the great thing about this is that, and you can see at the top of the buoy that's above the water, there is an antenna that comes off the buoy so that the data can be remotely accessed. So the water department can view the data real time in their facility, and we can set alarms so that when certain parameters exceed a threshold, the water department would get notified, and they can proceed from there. Number 3, we did bi-weekly synoptic monitoring. So that was when we were going out in the boat and we were sampling at the intake and the deep spot for a variety of things. So Secudis profiling, we were taking pores for a variety of samples, and then discrete grabs, as you can see, and of course plankton toes to assess not only cyanobacteria but also zooplankton that might be grazing on it. So, and then 4 was the bloom response. So that was obviously the most variable component of the plan, but that's where the if there was a bloom that was suspected, we had a response protocol in place to do some additional monitoring. We did have one false bloom where we thought it was a bloom. It ended up being water meal. But it was a good exercise because it did mobilize all of us. We treated it like a real bloom and did some extra sampling with that. But it ended up not being a cyanobacteria bloom. Okay, so for the cyanobacteria monitoring and response plan, we divided the plan into 6 sections. We obviously have like an overview of the drinking water system and a checklist to help the Meredith Water Department and volunteers prepare for each upcoming season on what they needed to do to get ready for it. Section 3 was guidance on monitoring for early warning signs, which I'll go over in a minute. These light blue sections are really the core of the plan. They're like the routine monitoring, and before you would move into these next steps. So it's kind of status quo, trying to find potential blooms, and if you feel like you have a bloom suspected, then it triggers these next steps. So section 4 would be actions if a bloom is suspected. Section 5 was actions following detections of cyanotoxins in raw water. And then 6 is kind of the ultimate if you found cyanotoxins in the finished water. So that means those toxins are potentially getting to consumers and causing health issues. So the deepening blue is kind of escalating response to those things. So I wanted to focus on the monitoring the early warning signs. So since there were no blooms last year, we did have to rely on the literature and some of the limited bloom history for Waukewan to just establish some preliminary thresholds for a number of bloom risk factors that they can rely on, at least least until if they get more bloom specific data. So certainly any visual signs of a bloom within a half mile of the intake would trigger some additional monitoring. Some of the on the sonde itself, if phycocyanin is above 1 RFU, it's just a relative fluorescent unit, that would trigger a response, or a ratio of phycocyanin to chlorophyll A would trigger that. And when you're actually sampling the water, either at the intake or the raw water tap in the treatment facility itself, again, we set a preliminary threshold to say if there's at least 5,000 cells of microcystis or 10,000 cells per mil of any other cyanobacteria species, that would trigger those samples to be sent off to a lab for toxin analysis. These other parameters that you see are obviously more climate related. So just as I was pointing out before, there does seem to be some correlation with rain events and air temperatures that may work well for early warning signs, or at least to have volunteers have more eyes on the water during those time periods. So when temperatures get above 24 Celsius, it's like 80 degrees water temperature, to understand that there's a higher risk potentially of cyanobacteria. And then also, if you have a number of calm, sunny days with little rain, there's a chance for cyanobacteria to come. And certainly if that's following rain or very high winds that might promote mixing, depending on the species that are dominant. So those are some weather conditions to look out for. Some other ones that we came up with, or was if water clarity decreased by more than ½ a meter or more between sample events. Again, that wouldn't necessarily suggest a cyanobacteria bloom, but if you did see that change, it would be check the sonde, have more eyes on the water for visual assessments to make sure that there isn't an evidence of a bloom. Within the water treatment facility itself, looking for any turbidity spikes that may not be caused by sediment, and making sure that it's not caused by cyanobacteria. If there's any taste and odor complaints coming from consumers, that would trigger some additional investigation. And then of course there's some other indicators as well. So if you start to have shortened filter run times or changes in in-facility pH, again, the water department would need to further investigate that. So in the report, we do have these decision trees, these like flow charts. We just have two. So this is the first one, and this is really where mostly they're going to be living and implementing this plan. So this is really just the early warning signs and trying to make decisions on if any of those early warning signs that I just went over, if they're triggered, if you have like a yes or no with any of these. And I don't think I can get my mouse over there. If it's a no, then obviously you're just continuing the regular monitoring. If any of these are a yes, then it's triggering that additional investigation, eyes on the water. Do you see a bloom? You look at the sonde. Is there any increase in phycocyanin in the sonde, being reported by the sonde? If that's a yes, then there's a possibility that there's a cyanobacteria bloom, and that would trigger you to move to the next flow chart in section 4, 5, and 6 of the plan. So I do want to show you some of the actions that we came up with for that. So this is, if you suspect a bloom, if any of those warning signs were triggered, this is the flow chart that you would go to. So obviously you're taking photos and samples and you're alerting partners of that bloom. If it's active within a ½ mile of the intake, those samples are being delivered to DES, where they will be identifying that cyanobacteria and counting them. If they get a sample and there is no cyanobacteria, it was a false alarm, then you go back to that other flow chart and you just keep doing your regular monitoring. If there is cyanobacteria, but it's a low count right at the intake or the raw water, basically you're going back again to your visual assessments.
is the bloom still active near the intake? And sort of on a daily basis, you'd be retaking samples and resending them to DES to make sure that those counts near the intake or the raw water continue to be below those thresholds, that 5,000 and 10,000 that you saw before. If they get a sample though, and it is above that 5,000 or 10,000 limit, then samples are taken not only at the raw water tap of the treatment plant, but also the finished water. Those are being sent to a lab for toxin analysis. They'll just do analysis on the raw water sample first to save on costs, because we want these samples, we obviously want a fast turnaround. We want to know right away if there's toxins in the water, and that costs a little bit more money for expedited sampling. So it's usually, you know, maybe around like $300 a sample for that. So we would test raw water first, and if those toxins came back elevated or detectable, then we would give the okay to do the finished water sample. Again, if no toxins are detected, you kind of go back, reassess the condition of the bloom. You might go back through this workflow to send more samples out. If it's detected in raw water but not finished water, you still want to send another sample, right? You want at least 2 consecutive samples that are below detection limit for toxins before you say all is okay, and you can go back to regular monitoring. If toxins are detectable in the raw water and finished water, then things escalate. So we go down this flow chart a little bit more, and within 24 hours, you're collecting another paired raw and water sample, raw and finished water sample, and sending that to the lab to basically confirm that those toxins are detected at not only before treatment, but after treatment that's reaching consumers. And if that's the case, then we're obviously sending samples on a daily basis. Most likely there'd be an immediate shutoff of the lake water intake, and Meredith would be switching to an emergency water reserve and discussing alternative water sources for Meredith. So it'd be all boots on the ground for that level of effort. As far as public communication, the town would get involved. It would trigger their emergency response plan with public communication and door-to-door outreach. More than likely, water tanks would need to be brought into the town to supply the water as this testing is being done. And again, we would not revert back to the water, using the lake water for drinking until you have at least 2 consecutive finished water samples that are below detection limit. And then once you have that, again, you're reverting back and continuing to monitor the lake and the bloom status. So this actually is timed very well for Meredith. So we're just finishing this drinking water grant, and we're moving now into another grant through DES, but through their Clean Water State Revolving Fund. So that's a loan with $100,000 principal forgiveness, and this project is to update the lake's 2016 watershed restoration plan. So within that project, we're going to be doing a little bit more than just a watershed restoration plan. One of the outputs of that is also going to be developing a municipal BMP's guide. So that's best management practices. It's going to be largely focused on runoff and stormwater management that the town DPW could implement on roads and town properties. But we really wanted it to be an easy-to-use guide that was specific to Meredith, but also potentially helpful to the surrounding towns as a very simple graphic design. So we've already started meeting with the DPW folks and have gone a watershed tour, and they are engaged in the process. So we'll be redoing the watershed survey and reprioritizing those sites that were originally done in the first plan. We'll be completing an ordinance review and providing some master plan update recommendations, which I know you're nearing the end of that process now. It's about to head into the public comment period. We'll be updating the water quality analysis and modeling. That will include a build-out analysis, an update to that, for the watershed, and also a nutrient loading model for the lake. And then of course we'll be updating the action plan, the water quality goal, and the milestones associated with that, with this new plan. And that'll be, we're just getting started now. We just had a kickoff meeting with the committee a week or two ago, and it'll be about an 18-month process. Okay, so to sum this up, there are some lessons from Waukewan as a model example. So first and foremost, if you're a community looking at what to do, continuing to monitor your lake and tributaries, whether that's through the DES VLAP program or UNH LNP, and continue, keeping your eye out for cyanobacteria blooms. Be sure to report them to DES so that they can maintain a reliable record. But monitoring is really the key piece that we need to understand, not only what the water quality status is, but how water quality conditions change over time in response to human activities and climate change, and also whether any restoration efforts are working. Second, we want to assess and plan. So use that monitoring data and the field surveys to develop a plan of action to protect or restore your lake. And then third, implement and educate. Once you know your issues and you have a plan of action, then do the action, educate your community about how they can help be lake friendly. And of course, none of this is possible without the necessary funding and support. There are many options for funding support at various levels, and there's a lot of folks that can help you find those resources. But especially, like I was emphasizing before with Meredith, and with teamwork, you really need to build your team. You need to build your network. I find that communities are most successful if they have one or two, what I'm calling local champions, or a point person that's steering the ship. But they also have to be supported by a broad network of partners to really make things happen. So we've already gone over some of the monitoring and bloom watching examples. I did want to focus, as I kind of wrap up, on these last two. So let's focus on the watershed management plan, which is really your roadmap. So watershed plan can really be boiled down into three simple components. So first, it's identifying the major sources of phosphorus through modeling and field surveys. It's really asking what are the major water quality issues and what is driving those issues. And then two, it sets a water quality goal that improves water quality, minimizes the risk of blooms, and this is initially based on at least meeting state water quality standards, but then it's further refined by local stakeholders who may feel that they have the ability to maybe make a more stringent goal. And then three, a watershed plan prioritizes actions to reduce the phosphorus sources that we identify in one so that it can meet the water quality goal that we set in two. So that's what we're doing right now for Waukewan and updating their plan. For implementation and education, addressing nutrient runoff is usually the #1 concern. There are so many actions that shoreline property owners can take to help minimize stormwater and erosion impact to water quality. The two key elements of slowing runoff are infiltration and filtration. So we essentially want to slow down the erosive power of stormwater to allow the ground to soak up the water and trap any unwanted pollutants like nutrients before reaching surface waters. And landowners can play a huge part in that by diverting runoff to gardens or other retention areas. You can stabilize your shoreline access points or pathways, maintain or enhance your buffers, and minimize the use of chemicals and fertilizers on your property. And there are a lot of resources available to landowners. You can sign up to become part of the New Hampshire Lakes or LWA's Lake Smart program. You can check out a number of online resources through local partners' websites, whether it be LWA, New Hampshire Lakes, or DES. UNH Extension has Landscaping at the Water's Edge. That's a great guidebook to some common practices. DES Soak Up the Rain New Hampshire program has a homeowner's guide that is also really great. And of course, there's DS shoreline rules fact sheets that are helpful too, and what you can or can't do, or what might need to be permitted if you're doing work in your shoreline. Have your septic system inspected, so important. At least every 3 years, if you're using it more frequently, or if you have a smaller system, you want to do that more frequently. If you are seasonal, you can get away with a little bit more, but 3 is kind of the magic number. Please have someone look at your septic system every 3 years to make sure that it's functioning properly. And then of course, if you're able to participate in any future grant opportunities that help to fund these improvements. So, if you're part of the Lake Waukewan community and you didn't know that we're about to update the watershed restoration plan, reach out to us, reach out to maybe Frank and Donna if you want to be part of that process. We want as many voices heard in that. And if you're not part of that community, if you're part of another lake community, figure out, what are your local groups doing and how can you be involved. For towns, but also private landowners, if you have private roads, road maintenance and training on proper road maintenance is really important. Road erosion and runoff tend to be one of the major sources of nutrient runoff to lakes. So make sure that municipal best practices are utilizing green infrastructure and low impact strategies that are focused on water quality protection. Manage your stormwater runoff and control erosion on roads and other town properties. And also minimize road, driveway, and sidewalk salting. There are training and certification programs offered by the state for applicators through the Green Snow program to help reduce chloride contamination, which is also a big problem for our lakes. Update ordinances and setbacks for water quality protection. Encourage low impact development, create low wake zones if you can in the lake to prevent shoreline erosion, conserve any large tracts of forested land that you have, land use ordinance updates and conservation land purchases that can help limit development or develop land in a more protective way are arguably the most effective strategies for protecting water quality. No matter how many stormwater controls are put in place, new development leads to more nutrient loading to lakes in all cases, no matter how many BMPs you're putting in. So minimizing that development and doing it in a smart way that's protecting water quality is going to be the biggest bang for your buck as far as future effort in protecting your lakes. And then education and outreach is also huge. That's a big part of what we're all doing here tonight. You're all part of a community connected to some beautiful water resource. So share what you learn with your neighbors and help each other. Lake protection it's hard work, and it takes a dedicated team connected to that broad network of partners that I was talking about to really be successful. So the fact that you're all here tonight is huge, and one great step in that direction. So with that is all I have for you tonight. I'm happy to answer any questions.
I just want to ask about, when boats go from lake to lake, and a lot more are just mooring, putting the mooring in Lake Waukewan. I live across the street from Lake Waukewan, so, I use town water. How does that cyanobacteria transfer on boats from one lake to another? Like, if they are coming from somewhere in Lake Winnipesaukee, where there was a lot of cyanobacteria areas around the lake last year. Can that be carried into Lake Waukewan or other lakes, you know, on the bottom of these boats? And would it be moving?
I'm sorry, I don't know why it's giving me feedback all of a sudden. Yeah, that's a great question.
You have two mics near each other.
I think there's only the one.
I'm just gonna slip it back in here.
Is this better? Okay. That's a great question. Yeah, so it's cyanobacteria are a natural component of all lake systems. So they just need the right conditions. So they're already there. They just need the right conditions to bloom. It's not the same as like an invasive aquatic plant that where material could come. But Amanda is the cyanobacteria expert, so she could probably expand on that a bit more.
Can we hold it for the panel? If we have any, if there's questions specific to Laura's presentation right now, we'd be happy to take them, and then broader questions about cyanobacteria, if we could hold off for the panel of experts, that would be ideal. Any other questions about Waukewan? Yeah, I don't know whether to bring the mic to you or just. Yeah, go ahead, Betty.
Has your firm done any consultancy on Winnipesaukee? Do you have any experience on Winnipesaukee? I know that you're focused on Winnisquam here, Waukewan here, but.
Yes. Can everyone hear me if I don't know what's happening on the mic right now. Yes, so FB Environmental has done most of the watershed planning around Lake Winnipesaukee. We started like Mulberry Bay Inlet, well over a decade ago, and we've been working our way around the lake. We're currently doing the last 3 sub-watersheds of Lake Winnie, so that'd be Center Harbor, Alton Bay, and then we're kind of piecing it all together with the Broads, which is kind of the leftover shoreline area. But there will be a complete watershed planning for Lake Winnipesaukee will be complete in the next year.
And then what happens with it? What
Yeah.
happens with the report?
Yeah, so obviously this has been like a 10-15 year process. So each sub-watershed that's gotten their plan, that community has taken it and they've worked with LWA to get grants to help with implementing those actions. So whether it's been going after state money through like their 319 program to make EMP fixes on like a road or a boat launch, they've done that, and certainly worked with the towns to try to update some ordinances, that sort of thing. So each community around the lake, as their plans have been developed, have been taking the initiative to start implementing that with a lot of LWA's assistance.
And what kind of ordinances? Like what specifically, what have you seen?
Yeah, so there's been a lot of, a lot of focus on like septic system, health regulation type ordinances, even obviously here in Meredith around Lake Waukewan, that was a direct result out of the 2016 watershed restoration plan, was updating the septic system ordinance. There have been like small tweaks here and there as we've been able to do it, right? Of like maybe increasing setbacks, distances from wetlands or lakes or property boundaries, right? Or maybe it's like secondary dwelling type ordinances. So they've been small tweaks as they've been able to like be passed through planning boards, or some towns might need like a vote, a town vote on something. So it's a slow process, but a lot of communities are trying to work towards that.
Frank?
Thank you, Laura. For everything you did last year, your efforts and expertise, DES too, of course. Just like a two-part. In the draft recommendations, there are some suggestions for increasing the panel of testing to increase our knowledge of the nutrients that would feed the cyanobacteria. And secondly, 3 or 4 years ago, you and DES helped us out with the sediment testing in water. I don't know if that's aging out, or you might recommend that we should start to consider redoing something like that.
Yeah, that's a great question, Frank. So if folks didn't hear Frank's question, we did have some recommendations for maybe continuing to enhance some of the monitoring, and particularly the parameters, maybe adding some more parameters to their existing monitoring program. So he was asking about, maybe the value of some of those additional parameters, and then also the sediment testing. So we took some sediment cores on Lake Waukewan two summers ago. Yeah, 2 summers ago. And that was to get a baseline assessment of the amount of phosphorus that's in the sediments of Waukewan. Knowing that internal loading is happening in Waukewan, it's not significant to take any action on yet, but we're just trying to set ourselves up, getting the baseline characteristics so that we can understand if that changes over time, right? If it gets worse. So with sediments, they're fairly stable. It takes a while to rebuild a sediment layer. So every 5 years, maybe even every 10 years for sediment analysis would likely be sufficient, assuming that watershed conditions remain relatively the same, right? If we have back-to-back years with very intense rain events that send a lot of material into the lake, that would enhance that sediment accumulation. We might want to rethink that frequency, but we can extend that frequency out. For the water quality parameters, we did find some interesting correlations with like iron and manganese, so there were some recommendations of maybe trying to incorporate that into testing in the future. And also, nitrogen is also an important nutrient. I know we focus a lot on phosphorus, and it is typically the limiting nutrient, but nitrogen also plays a big role, and can drive cyanobacteria in a way that's a little bit different sometimes than phosphorus with just inhibiting growth. So it is important to get a handle on how much nitrogen is available and the different fractions of nitrogen. And then with Waukewan, with the internal load, we were trying to maybe increase the frequency of phosphorus that was collected at various depths in the lake, and that was really to supplement the ability for us to calculate the internal phosphorus load on an annual basis and feel confident in that number so we can track that over time, because it is something that's variable and has a range. It's not going to be the exact same every year. There are certain environmental variables that would make it higher or lower every year. So having enough data to come up with a confident estimate will make us more confident in how that's actually changing over time, right, and understanding the trends. So I know there's a ton more to go into that, Frank, so if you have any follow-up questions, we can talk about it.
Okay. Anybody else for Waukewan specific questions, or? No? All right, well, with that, we'll take a 5-minute break, try to get the mic fixed, but please feel free to have some snacks, some refreshments, make your way around to the tables that are set up from the various lake associations, and talk to the people that are next to you, making new friends. Stand if you would prefer, but doesn't matter. It doesn't matter. Yeah. Yeah. Right. All right, welcome back. Thank you all for sticking with us. We're now moving to the second half of our evening, which is a panel discussion featuring experts that work across New Hampshire to understand, monitor, and respond to cyanobacteria and water quality issues. So please join me in welcoming Amy Smagula, Chief Aquatic Biologist and Director of the Jody Connor Limnology Center at the New Hampshire Department of Environmental Services. If I turn
this off, can you all hear me better? Okay, great, I'm gonna do that. Pierce Rigrod, the supervisor of the Source Water Protection Program at the New Hampshire Department of Environmental Services. Amanda McQuaid, UNH Extension State Specialist and Professor of Water Quality and Ecotoxicology and the Director of the Lake Slime Monitoring Program at the University of New Hampshire Extension, formerly the Harmful Algal Bloom Coordinator with the New Hampshire Department of Environmental Services. And then last but not least, Laura Diemer, the Certified Lake Manager, Senior Project Manager, Lake Services Lead, and Director of Operations for FD Environmental. So what I would like to do to get started is just let our panelists talk a little bit about the work that they do and then open it up for discussion from all of you. Amy?
Want to go down the line?
Sure.
All right.
Yeah.
Hi everyone, Amy Swagula. As Bree introduced me, I am the supervisor of our State Limnology Center. Our group has about 12 biologists who are responsible for monitoring surface water quality across New Hampshire, lakes, ponds, rivers, harmful algal blooms, invasive species, and other things that are going on in our waters. So tonight I'm here representing our harmful algal bloom program at the Department of Environmental Services, and we take in samples that you guys report, not necessarily tied to drinking water supplies, and we analyze them. We do identifications, we do cell counts, and then we're the ones who update the Healthy Swim Mapper that is online to let you know where the blooms are across the state, and we keep track of warnings that are issued. So if we have a bloom and we have 70,000 cells or more of a cyanobacteria, we issue a warning for a water body. If we have cell counts that are less than 70,000, but we have concerns about that, we may issue a watch. Otherwise, we just track identification, location, and count, and put those numbers on the map so that you as recreationalists or homeowners on a water body, you can access that information and see real time what we know about blooms and have access to that data. So I am representing that faction tonight.
Well,
I obviously just talked to you all for an hour. Basically everything you heard from me tonight is what I do on a daily basis, but much of what we do is develop watershed management plans for communities like yourselves. So if you want one, talk to me. I can help find funding for you to get that done. And of course we do, monitoring work and that sort of thing. So I will leave it at that. Amanda.
Hi, my name is Amanda McQuaid. I'm with UNH Cooperative Extension. I was with DES for a little while too, so I probably talked to most of you on the phone about blooms here and there. Now though, with the Lake Slime Monitoring Program, we're a volunteer-based program established in the 70s actually, so a really long-running program, very similar to VLAB. Our goal is really to keep monitoring, and we also have a little bit of leverage with the university to work with students and to do a little bit of research as well. So I guess I represent more of the university side of things, but I also really closely collaborate with everybody up here, a lot of you here as well, on a lot of different projects. So we're sort of an option for helping monitor, sample, lab processes, or other ideas regarding research and water quality. Thank you.
Hi, I'm Pierce. I work at DES in the Drinking Water and Groundwater Bureau. As I was said, I supervise source protection, which is protecting the state's drinking water resources, so the lakes, rivers, aquifers. And as part of that work, we also do cyanobacteria monitoring. Back of the room is Liz Palanzi, who has been working to monitor Waukewan for the last 2 years. On a regular basis, we track that information, and we also provided over $1 million to ramp up monitoring in major water systems, including Meredith, but also Manchester, Salem, Portsmouth, and we're now about to do the same in Waukewan to produce these monitoring plans and to do a year of monitoring. So we have a better baseline for what kind of dynamics are going on in the water system to avoid, essentially to avoid exposures to cyanotoxins. So I can tell you it's been, I've really wonderful to have FB and to all the partners that we've been working with. A lot of our work is integrated with the partnerships that we formed through our program. We're currently working, so we do the implementation piece too, so we try to support the watershed plans through grants. We've provided 8 grants to Meredith and Waukewan over the last 16 years, so every other year we're providing implementation grants to do things like change health codes, to evaluate septic systems along shorelines, to support land conservation, and right now we're about to start working with the Lakes Regional Planning Commission to work with them on auditing codes in this region to accelerate low impact development projects in communities, because those types of stormwater projects are much better for water quality, and we expect that over the next year or so there'll be a lot of discussion about how we change codes. Because if you didn't notice, we're in a housing crisis. So there's going to be a lot more building of houses, and that has an effect upon watershed and water quality. So one of our priorities in this region is to accelerate better stormwater practices, some of which we've also installed through our grants.
Does anyone have a question to start us off? Frank?
Yeah, me again. With Laura's stated emphasis on observation and just analysis of watching the watershed and going out and seeing what's going on the lake itself. I guess maybe I'd start off with Dr. McQuaid in terms of how do we go about seeing Cyanobacteria, and how do we measure it, how do we observe it? How do we determine, diagnose, and what else we need to do?
Okay, sure. Yeah, thank you. So this question is about these other types of cyanobacteria. The pico cyanobacteria are invisible. I hate to bring this up to this group. We're looking at these surface scums that are blooms that are a very different thing than some of the other cyanobacteria that do exist. I won't take over this entire panel and talking about the different types of cyanobacteria. What we're doing with the pico cyanobacteria, because they're so small, they're the most abundant. They really recycle through the food web very quickly. So UNH has an interest in these tiny organisms because we think that they could get incorporated into the food web more readily, that they could probably aerosolize more readily, and that they tend to be more symbiotic with other things. But so far, we're not finding them to be very toxic. It's just another piece of the cyanobacteria puzzle. So one thing that we got to do with Waukewan, which is an excellent kind of add-on to looking at this lake, where we weren't sure, would there be a bloom? We weren't gonna hope for a bloom, right? But we wanted to monitor all avenues of potential exposure, knowing that, that Waukewan might not bloom while we're monitoring. Pico cyanobacteria are always abundant. Could we learn something else as we were going? This was an awesome project that we did where we were basically filtering water, tons of water. We're trying to get huge biomass of these tiny, tiny things. So nothing that you guys would necessarily see bloom. There are a few lakes that do bloom with these picos. One of them was Nippo Pond, actually. That was another lake that got the treatment back a few years ago. But rarely do we see picos bloom, but it is something that we might start to see more of, and it really is contingent on the food web. So we worked with Bigelow, and we also worked with some people at UNH, and there's a lot of new developments going on with quick PCR primers to really look at different cyanobacteria, and then the Genome Center that can kind of do a huge sequence. So we do have some added data from Waukewan that shows some abundance of pico cyanobacteria. We did through gene sequencing with Bigelow and the University of New Hampshire Genome Center. Those results, I know there's just too many results to share, but I think they're interesting because we just don't know a whole lot about them. So they're kind of still at the research side, but still an interest in how we are exposed to cyanobacteria. There's still some thoughts about breathing them in, aerosolized neurological diseases. So much we don't know about toxicity. In fact, there's new toxins being discovered all the time. So sometimes we get really hung up on toxicity, but it's really when we see a lot of it that we should be concerned about seeing a lot of microbes. The picos you wouldn't necessarily see, but they do, and they do bloom, the whole lake kind of goes turbid. So they won't really be that typical surface scum. They'll be like the water's starting to look kind of green. So some of the lakes are experiencing that, and we just don't hear about it because they're not really surface scumming. But they could be a low risk, just a whole other category, one of the most numerous organisms in the world, actually. Sorry to say, but I think they're interested.
There's been a lot of acronyms, program acronyms tonight, but I might put Amanda on deck again. But I saw the lay monitoring program. Does that mean non-science citizens gathering data? How many of those programs exist? Is that the best place to start with UNH, or are there independent or local other entities doing that?
There's a lot of options. I'll just speak to the name. It was created by some professors at UNH in the 70s, and they decided, I think it was Lake Chocorua and Squam that approached them and said, hey, we want to monitor. What should we know? What should we do? And so it became that like lay term. Then a few years later, the Volunteer Lakes Assessment Program came out of that. Since then, we do have lots of regional groups. LWA does monitoring. We have Green Mountain doing the Ossipee region. We have Newfound Lake and the AmeriCorps and Squam Lake doing stuff with their AmeriCorps. They're hired now. They're not really American, whatever. Anyway, we have a lot of different regional groups that are working on the monitoring and training. And so if you are interested, especially if you're with Winnipesaukee or some of the groups that Lakes Lay have been traditionally working with, Bree and I could talk to you about that. If there's another one, like some lakes that have been in the Volunteer Lakes Assessment Program have been also, pretty loyal for 30, 40 years. But there are these other like little regional groups popping up that are being trained and can do it too.
Great, thank you.
Yeah.
So, back to you.
I was fascinated by Laura's graphs that showed the correlation between water temperature, rainfall episodes, and then subsequently blooms. Amanda, when you get a monitor spike that you have to issue a warning, is that done within a 24-hour period? How quickly can you turn around a sample and an alert? And secondly, do you look forward from that point and say, well, it's going to be hot for the next 3 days and there's no wind? Can you be predictive of, to some extent, of how long the bloom might last?
So do you want to, okay, so yeah, I'll start on that one, and then Amanda can certainly chime in from the cyanobacteria background. So when we are alerted about a bloom, we're asking everyone to use our bloom report form, which is a pretty comprehensive online form that allows you, the individual, to enter data that lets us know where you're seeing the bloom, how prevalent the bloom is. You can submit photographs of what you're seeing to better inform us of the bloom. And then if you can submit a sample to us in Concord, that's fantastic. If you can't, we do have the ability to have an intern come out. We do try to turn the samples around within 24 hours. I do have to tell you that we do have a person that's temporarily covering our cyanobacteria program because we are in a state hiring freeze and we can't fill that position. But even with that, we're still trying to do a 24-hour turnaround, at most 48. At this point, we do have a fairly good understanding of what a lot of our lakes are doing in terms of blooms. We do have some lakes that bloom for days or weeks or months, and usually a lot of the more nutrient-enriched systems are the ones that tend to bloom longer. Not always, but often. So we can be a little bit more predictive about how long this might happen. Of course, this is a natural organism in a natural system that is going to respond however it wants to respond. But seeing some of Laura's data with the temperature trends and the precipitation trends and the bloom response, that is information that informs us about what we can expect. We also had some other people in our agency who were looking at some other water temperature trends and how those influence blooms as well. So I think, like Amanda was saying, the more data we gather about these environmental systems, the more we can make informed predictions about how long these blooms are going to last. Another thing is too, we've been seeing one bloom transform into another bloom. So you have one species that's dominant, and then it's superseded by another species that becomes dominant, or they commingle. So these blooms are never static. They're always dynamic over time. So we will go back out and collect samples to see what it's doing, if the density has changed, if the species have changed, and that will continue to inform our decision. So instead, and this is one of the things that you guys are gonna notice that's different this year, we had a lot more warnings in the past. So we would get a report of a bloom, there'd be a little ribbon or a little bloom on shore, and if those cell counts were over 70,000, we would issue a lake-wide warning. We are trying not to do that anymore. We're trying to be much more strategic in how we are sharing information so that you guys can make a much more informed decision. So that mapper, the Healthy Swim mapper, is updated with points. So if you see a black point, that means that we had a report, it's less than 70,000 cells, or we don't have a sample, but we know something was reported. If it's orange, it's almost 70,000 or it's less than 70,000, but it is a cyanobacteria. We looked at a sample, we know what it is. If it's a red point, it's over 70,000 cells, we know it's cyanobacteria, we know it's approaching something that we would be concerned about for a warning, but it's 1 point. 1 point doesn't make a bloom for a lake, or a lake-wide warning. So that's when we want more information to come into us so that we can make a more informed decision based on all these points around the water body. So the more reports, the better, so that we can make that decision. And then we will update those points regularly. So you always know what's going on. It's sort of a real-time mapping of a bloom, as best we can without being out there 24/7. So, does that answer your question? Okay, great.
Jamie?
Sure. I think it's not a good question, but just to kind of follow up on what you were saying, most people equate VLAB with summer sampling. So when the weather's nice, we're out there collecting samples in the lake. But can you just maybe address the value that sampling on the shoulder seasons has, and then especially sampling over the ice? We've done 3 seasons on the ice now with some mixed success, I guess. But can you just touch on what value that may have?
Sure, yeah, I'll can comment to that. We would love to get out on the lake all year round, and whenever the ice is good, sometimes we'll get like one good day. So we do encourage all year round. But yeah, a lot of people are seasonal, maybe not here, I don't know. And we do rely on the summer volunteers largely in the program, but we do have some special projects. We've done some ice out with Winnipesaukee. You guys did a lot of ice out this year. Sometimes we'll do added, but I do think there's a benefit to getting every season. As Amy pointed out, like right now we're in the spring, this is a successional thing. So we can start to see, just what might be starting to grow early spring. But then that does tend to build up over time. We get more diversity of organisms. And by the fall, and in fact we saw with Canisaka into the Winnie spillover, that was like late October. So we want to be able to get the dynamic differences over time. And one thing the DES has suggested is maybe doing more plankton analysis over time. So that could be something that we could start to do to kind of see what's living in the system and how they're changing over time. It doesn't give us a lot of information regarding management, but it does give us just a little more information on the health of the lake and to maybe be able to predict patterns. I do think that the data that Laura showed is just straight out of what everyone says and sees all the time. They're like, well, it rained a lot and then it was hot and sunny, and then people are getting to the lake maybe and seeing like, well, it was raining, now it's calm and sunny, and now the cyanos are right here. But they've been growing in the water column and they've been moving up and down throughout the lake for the entirety of the year. They really don't just go away entirely. So yes, the more monitoring, the more understanding of these seasonal dynamics is important, but we also realize, volunteers can do so much, we can do so much. It really takes like the special group to kind of come together and make it work. But when you have the resource and you have the ability to do it, it's advisable for sure. Yeah, you guys want to add anything to that?
Somebody else have any questions?
Yeah.
I'm gonna ask Pierce, unless somebody in the back, yeah, anybody?
Well, I just have a dumb question.
So if there's a life cycle to the actual microorganism, is it cumulative to the point where we know they move up and down in the water column and they rest down, they overwinter at the bottom, and they come up spring alive when the sun and the heat and whatever, like, is there a multiplier effect so that this is just continually gonna get worse and worse and worse and worse? You know, all things being equal, in a static world where, you know, water infiltration and the same temperature and the same sunlight, does it get concentrated more, you know, if it's not dying?
Oh, it's just so complicated. Every lake is so different, and as it's changing, it's kind of like tracking someone in their entire life to know, like, what did you eat? When did you eat that?
Okay.
How did that happen? Did that build up, you know? But at the same time, yes, we do see patterns. Like right now, we mentioned Dolichosperma. It's gonna co-occur with the pine pollen. They're the same size and buoyancy. They look identical under the microscope to some degree, but they're just seasonal. It's like why we have seasonal pollen, we have these seasonal types that like to do well at this time. I think the misunderstanding of blooms is that they're not just growing where we see them. They're really kind of driven by the wind and the flow, and so although you might say, I'm at this beach, I'm gonna report this is the point, that is really informative for advisory purposes to understand exposure, but to know that it didn't grow there and just fester. It grew out of the lake, it got caught in the surface tension, it kind of got blown over with the pollen. And so looking out for accumulations is probably the best, you know, risk assessment. Like, I think I should stay out of accumulations, but knowing that it's not necessarily the location that you find it that's the problem, right? But we do have some benthic mats, we do have some, like, there's a lot of different types of cyanobacteria. They are just as different as plants and how they survive. So food web could be a big part of what, you know, you're saying is like, could it just get worse? Well, there could be like a super organism that comes in and eats it down, and then they can't survive. So there's just like such a dynamic process with all of them.
Does it ultimately affect the zooplankton count, like the health of the rest of the water body,
Yes.
other than our health? And
Yes, yeah.
Yeah, so it's,
That's where I could talk a lot more, but yes, yeah, it's interesting because there's certain organisms that could consume it just fine, but then it depends on what type. But then we've seen evidence that they don't necessarily like to eat it. It's a poor food source. It's like, oh, I guess I'll have to eat it. It's like, I don't know, drive-through or something. You're like, oh, I'm starving, I'm gonna go right now, right? So it's a dynamic process, but there's so many elements. There's micronutrients, there's like so much to say about iron and nitrogen and dissolved phosphorus and things that we would like to do more of, but it's such a dynamic process that you could miss it too. So going to the deep site is great. We get like our you know, our annual doctor's checkup, but then you're like, well, there's something going on over here, let's go check that out. Then you might need to get a specialist involved or something more to really get closer to the shore to see if there's maybe a tributary that's really causing the problem. I think Mirror Lake is a great example of a lake that's done a lot of work in the watershed, identified some issues, and we're already seeing like an improvement in water quality over a relatively short period of time. It is it's not like a stark, like, whoa, it's totally good now, but I think we're at this tipping point right now where we're gonna have to accept that we're trying to just hold our ground. We're just trying to hold water quality. If it could get better, great, but obviously development is something we all need to deal with. Salt roads is everything we need to deal with, and it's all connected. So if that salt affects the zooplankton and the zooplankton can't eat the cyanobacteria, they're like, oh, I'm gonna do fine this year. So it could be as different as like your garden, where you're like, why aren't my, flowers doing well this year? It can really be so many different things. But yes, if we continue on the path we're at now, development, climate change, nutrient input, yeah, it's just gonna get worse. I know,
Here's,
it's
I
fun.
want to ask you a question, if that's okay.
It is. But let me just say first that
Yeah.
Bree used to be my intern, so I think
did.
I'm here partially because of that. But I want to say also how lucky you are to have her. She's amazing, and can I sit down.
Yeah, you really want to. So my question is, can you talk a little bit about the restoration projects that your group has done to be able to facilitate in the area, and maybe give some specific examples of projects that you've done to help remediate stormwater runoff specifically?
Well, stormwater, we put in, so we focused on Paugus Bay because that's the main supply for Laconia and Waukewan here in Meredith. And I could say at Paugus, we had a really great project in 2008 where there was a pipe essentially coming off of Cast Point that was basically discharging right near, into the bay, the southern part of Paugus, where the water was essentially just running off the hill through a pipe and then into a ditch and then across into the bay. And we were able to work with the DPW for really a very low number, to put in a bioretention swell. And that took all of that rainwater, put it through a series of media, engineered media, organic plants, a whole ecosystem was formed to treat this water prior to discharging right into the bay. We need to do more of that. We're funding a handful of projects, many of which through the LWA, to understand where we should be focusing our energies on nutrient controls. Where in Langley Cove, for instance, we have had two projects, one to focus on where phosphorus is making its way, or likely making its way into Paugus Bay as well. In Meredith here, probably the most impactful non-point source project we've done is back in 2008. We funded and we worked with our watershed folks to pay for septic fixes. We had a project that essentially involved an on-site evaluation where we were popping, and a certified evaluator was popping the tanks, looking to see if the septic systems were in failure or failing, and then a volunteer effort, voluntary program to receive money from us to fix those systems within 250 feet of the shoreline for Waukewan. So of the 24 or so systems that were evaluated, just over half were in failure. So there were a lot of systems that at that time in the group that we looked at that weren't doing very well. And of course, that's a major supplier of phosphorus. And if you're right on the shoreline, that's a direct conduit right to your lake. So we also worked with John Edgar at the time to adopt the code in this town that now requires evaluations on a periodic basis if you don't have a DES permit, which means you may have a system from 30 or 40 years ago, which was a stone, a pipe, a 55-gallon drum, and a stone, filling that before it goes into the ground or into the lake. So we have, like I said, we have about 8 projects currently over the last 16 years, and we want to keep doing those projects as we can have funding. We have small grants. They're not huge grants, but they can do the design work. And when we have partnerships with municipal officials and departments like the DPWs, these projects can take root, and they can make a big difference in terms of nutrient, feeding that cyanobacteria with phosphorus and other non-point source pollution.
Thank you. Anybody else have any other questions?
I have an easy one. So you have a family that just moves up to the Lakes region and spends about $5 to $10 million on their lakefront property, and all of a sudden they have a cyanobacteria bloom in front of their house. What positive information can you give them?
What information?
What positive information can you give them about what they should be doing with the bloom in front of their house?
That's a great question. Do you want me to answer that? Somebody else? Better speak. Okay. So I would say that, again, just to Amanda's point, just because they're seeing a cyanobacteria bloom in front of their house does not mean that, that one property specifically is doing anything negatively to add nutrients and to help feed that bloom. They move with wind and wave action, right? So at the end of the day, it's really a wake-up call for them that, your kids can't be swimming in the water, you shouldn't be pulling from it for drinking water purposes, your pets can't go in, that sort of thing. But in terms of how to reach them, it's education and awareness. So the presentation like we're doing tonight, or, the various cyanobacteria committees that we've set up around town, DES, UNH, FB, all all of these entities and all of this information that's out there, but they need to be willing to be able to seek that information out, right? Which can sometimes be difficult or a big barrier, but that's something that LWA is working on, is to contact folks that are new to the region and let them know that we exist and that all these other wonderful resources exist as well.
Is there a problem that could happen where a child gets in the water with a balloon and all of a sudden that child develops a neurological problem? Is the state of New Hampshire responsible for responding to that properly?
Responding to it from a standpoint of doing an investigation, collecting a sample,
Yeah.
we would certainly do that. We're happy to take a look at a sample and identify it and see what it is, do the count. The only thing that we don't do right away is toxicity testing. So just because cyanobacteria is there doesn't necessarily mean it's toxic or not. So that's why we use the cell count as an indicator for if it could potentially be a problem. But yeah, we would absolutely take a look at that sample and let you know what it is, if it's a cyanobacteria, and then go from there.
So bottom line, you make them, how do you make them happy?
I honestly don't think anybody's happy when they're seeing a cyanobacteria bloom. So there's really, I mean, it's an unfortunate thing. We're seeing it more often, and it's just a reality of living on the water. Blooms are happening more often. I mean, Amanda's definitely the expert who does a lot of very technical cyanobacteria IDs, but there are a couple of us in the room who also do plankton counts and have been doing plankton counts on our lakes for almost 30 years. And I can tell you that I've seen the number of cyanobacteria increase and the diversity of cyanobacteria increase in lakes across New Hampshire. So they're just on the rise, and all the things that Laura talked about and all the things that Amanda have talked about, they're adding up, and we're seeing the signs of impacts to our lakes. So all of the stuff that Laura had at the end of her presentation for things that individual property owners can do are significantly important for slowing down that rate of impact to our lakes and keeping them, or slowing down the rate or the frequency of those blooms. It's absolutely critical.
So, thank you to our panelists for being here tonight, Amy, Pierce, Amanda, and Laura. And for sharing your knowledge and your time and your insight about all of these different really important topics, and also for being mentors to me. So thank you for being here. To all of the volunteers and committee members, community members, and lake associations who participated tonight and made it possible, thank you to you all as well. Before you leave tonight, we do have a post-presentation form that we would love for you to fill out. It's a half sheet, just a couple quick questions. Your input helps us plan future events and also better serve our community and know what you want to hear about. So thank you all to you for taking the time out of your evening to be here as well. Your presence tonight really reflects how much our community values our lakes and how seriously we take the growing risks and threats posed by cyanobacteria. Events like this truly happen because people care enough to show up and speak up and stay involved. And these conversations are really where solutions begin. And we're so grateful that you were here tonight and to be working alongside all of you. So thank you. Enjoy the rest of your evening. Please take one of those post forms. Joanne has some right there. There's also some on the sign-in table. And thank you.
Photo of everybody together before the breakup.